When the game starts, rocks enter from the right side of the screen and glide until they leave on the left. The dragon moves left, right, up and down when the microbit is tilted. If you guide the dragon through the rocks, the score increases by 1, but if the dragon hits the rock, the game is over. The first task is to program the second pipe sprite to enter from the right side of the screen and to exit on the left. To do this, copy the first code from the pipe sprite. Notice that part of this code involves showing the score when the broadcast play is received. By using abstraction, children will realise that this part of the code is unnecessary since it is already in the first pipe sprite, therefore we can discard it. By duplicating this one piece of code, the second pipe is creating a clone of itself, but is not showing for the dragon to be able to fly through it. Therefore, we now need to copy over the next piece of code which causes the pipe to show. As you can see, having this code in this sprite causes both pipe sprites to appear on screen and leave at the same time, which brings us to the next challenge, which is to make sure that the pipes enter the screen at different times so they do not overlap. As you can see, both sprites create a clone of themselves every 5 seconds and therefore enter the screen as soon as the clone is made. To stop this, we need to add a wait block to the second pipe sprite, which will cause it to wait a certain time before being shown on the screen. Let's try 1 second. Although this appears to work, it is noticeable that there is long gaps in between the pipes. Therefore, to make the gaps even, I will change the wait time to 2.5 seconds. As you can see, the pipes are now running successfully at different times, but you cannot see the difference because of the costumes for the sprites being the same. To change this, I've loaded a different coloured rocks pipe sprite into my backpack, which I can transfer to my second pipe sprite and remove its original costume. This successfully meets the outcomes of task 3. The next 2 tasks focus on the score, with the first requiring that when the dragon flies through the pipe, the score needs to change. To do this, we can duplicate the score for the first pipe sprite. This will cause the score to increase by 1, however we want it to increase by 2, so we simply need to change the score variable to add 2 instead of 1. The code is nearly finished now, yet you can see that even when the dragon hits pipe 2, game over is not being broadcast. This means that we have to go into the dragon's code and decompose it to find the code which causes the game over to be broadcast. Here you can see code which states that if the dragon hits the ground or touches the pipe, game over will be broadcast. In order to account for another pipe, I will change the touch sensor from ground to pipe 2, meaning that the game will be over if either pipes are touched by the dragon. Lastly, the pipe 2 code needs to stop when the game is over so that it is no longer entering the screen, and this is achieved by copying the code from pipe sprite 1, which simply states that when broadcast game over is received, all other scripts in the sprite should stop and it then should hide. This is an example of a coding and debugging activity which can be used by children for them to adapt the code, fix errors, and use logical reasoning to predict the outcomes of any changes that they make to algorithms.